Alright, this is a simplified problem for a radical. And so anytime we're trying to simplify radicals, what we're trying to do is get powers that are going to match this index here, so exponent powers here that match. And when they do match, we can actually bring them out. Essentially, the radical ends up simplifying, and that's because of our rule. If you remember our conversion rule, it says if we have the nth root of x to the m, that is equivalent to, see if you can see that, okay, converting that's x to the m over n. Okay, so when these match, that reduces down to be a 1, and that's how we can pull these things out. Alright, so for the 288, what I'm going to do starting here is just break this down into its prime factored form. And so it breaks down into 2 and, excuse me, 144. And then 144 breaks down into 12 and 12, and that's 12 squared, but we're not looking for squares, right? We're looking for fifth powers. So we're going to keep breaking these down and see what we end up with here. And so we want to look at the endpoints of our tree here to be able to write out the prime factored form. Okay. Alright, so what I see here for the prime factored form is I see 1, 2, 3, 4, 5 2's and a couple of 3's. So 2 to the 5th times 3 squared is how we could represent 288. So I'm going to rewrite this, and I'm going to write the 288 as 2 to the 5th and then 3 squared. The x to the 17th I'm going to represent as x to the 5th 3 times, so that's 15 x's right there, right? And then we've got 2 left over, so there's 7, gosh, my hand's in the way, there's 17 x's right there. And then we have y to the 30th, which is actually 6y to the 5th. Let's see if I can get that in here before we run into that. So that's, okay, I'm not getting that in there, that's 4 of them. And 5 and 6. Oh, those are, sorry, these are all fifth powers. Not, okay, let me just redo that. Let's get a new piece of paper. So this is going to get converted into the 5th root of 2 to the 5th, 3 squared. We're going to have x to the 5th 3 times, so that's 15, and then 2 left over, that's 17. We have y to the 30th, so we have y to the 5th 6 times, essentially. That's better. Okay, so that's what this 5th root here of 288 x to the 17th and y to the 30th is equal to. Now, we can start bringing stuff out. So the 2's coming out, we've got 3 x's coming out, and all 6 y's coming out. And so we have 2, we have x to the 3rd, we have y to the 6th, and then we are left with the 5th root of 3 squared, which is 9, and then x squared on the inside. Now, I do want to mention here that the directions just said simplify. In this particular book, they are telling us to assume that variables represent positive values, so we don't have to worry about any absolute values around anything here. This is an odd index anyway, so we wouldn't need to. But so this would be our answer here in this problem.